introducing you to our next panel, going to a different type of way of delivering edge solutions. This one is developments in mobile antenna technology. Here we are at a DAS small cell conference. We've got to talk about some sort of antenna technology and where this is going. So here to moderate, you've listened to him earlier, Mike Sapien, who's an enterprise analyst with the research firm Ovum. He will be joined by panelists Art King, Director of Enterprise Services and Technologies for Spider Cloud Wireless, Greg Toback, Field Sales Engineer for Anritsu, Wade Sarver, blogger, podcaster, Wade for Wireless, and Arnold Kim of ADRF, Advanced RF Technologies. So thank you very much, everybody. Thank you. Make sure you put it in the right direction.
Yeah, that's all right. It's not easy. All right, hello again. We'll go through, just go into the panel right now to start this off, and I'll just paraphrase this. First of all, Arnold has been replaced by Greg, so Bob, I'm sorry, by Bob. Sorry about that. So Bob will be sitting in for Arnold, so we don't see him there. Secondly, just a quick intro to the session. We've kind of paraphrased this as more about the mobile infrastructure technology, including the antenna. So you're going to hear from a number of the players of the mobile ecosystem and vendors that supply that ecosystem. So with that, I'll kind of speed this along a little bit and say we'll start with right now just kind of quickly an intro by each panelist and their role in this mobile ecosystem, including the antenna. So with that, Greg, please.
Can everyone hear? So Anritsu Company started just over 120 years ago as the first power company in Japan and the first RF company in Japan. Shortly after the two-way radio was invented by Marconi and Tesla, Anritsu had developed their own two-way radio. We fast forward into the late 20th century, Anritsu had acquired Wiltron. Wiltron was the inventor of the SiteMaster, the first hand-portable VNA that was capable of doing distance default, return loss, and VSWR measurements for traditional coaxial systems. In 2005, we acquired NetTest, based out of New Utica, New York, who manufactures handheld OTDRs and other fiber optic testers for fiber testing solutions. So we look at today's convergence of markets in the wireless DAS environment and the carrier macro cell environment. And we notice that the markets are now developing an ecosystem that synergizes copper for wireless, fiber for wireless, and microwave, cellular over microwave. So Anritsu developed several solutions for these markets, and the way we address the DAS environment is we address it through the use of all of these technologies and designing for testability. We'll speak to design for testability a little bit more as we go on. But one of the key challenges that we face today is being able to quickly, powerfully test, develop reports and strategies to deliver the necessary reports that carriers can use to get their KPIs and to measure the metrics by which a DAS environment can be communicated through in its lowest latency and its highest demand. With that.
All right. Thank you very much, Greg. And Bob, please go next.
Hi, everyone. Bob Langston. I've been in this industry for a little over 20 years. Most of my role has been system performance and capacity development, macro, micro, all flavors, power amplifiers, antennas, TMAs. I've done business development in Europe and in North America as well. Really the same sort of environment: antennas, power amplifiers, GSM boosters, tower-mounted amplifiers, ground-mounted amplifiers. A lot with optimization, a lot with coverage and capacity. The bottom line is, I go into the DAS world, there's no difference. You've got an RF source, you have a transport, you have a mobile, okay? When you get DAS done, you can do it low power, let's say. I did it at the Hilton here in New York Metro. Radio unit, the RAW, was close to the antenna, maximize the performance on the downlink. That's the good news. The bad news, electronics in the ceiling, aesthetics, antennas. You have radio pieces in the ceiling, maybe in sheetrock, maybe in soft ceilings. You have antennas that need to be tethered to stop droop in replacement tiles. You look at high power. We did this in the Sheraton in Midtown. The same deal. Large passive network, good antennas, wide range antennas, making it future-proof. Therefore, your GSM, UMTS, LTE, and beyond, you're good for that. Real estate issues, 200 Park, the MetLife building. $3.5 million worth of low-power equipment sat in a warehouse for 2.5 years. Reason being is the landlord did not like the idea of exposed antennas and thought that her tenants wouldn't want to be in that environment. Over those couple of years, calling on them, granted we requoted it with about an 8 to 10 dB difference in downlink. That increased the buy to well over $6 million. The carrier went back to respin their wheels, figure out how we're going to fund this. And during that time, it totally eclipsed the landlord, came to us and said, exposed antennas, we're good. I see them everywhere. So that job went in, it finally got built, and 2 years later, it went on the air last week. Again, RF source, transport, mobile. It's all the same.
All right, Bob, thank you very much. And now Art, please, from Spider Cloud.
Yep. So we're kind of a different vendor in that we're a small cell vendor. So we build, for Verizon, we build a radio that's a band class 4, band class 13 small cell. Fits up in the ceiling just like a Wi-Fi AP. Uses Ethernet IP transport to connect to a box called the services node. And that connects backwards to the mobile core. So there's essentially a cloud of small cell radios coordinated in the building that are Ethernet attached. On the front side of it, there's 4 antennas inside the small cell, 2x2 MIMO, and it's just a 24 dBm transmit level. So it's not a very high transmit power. And we also build a exterior antenna version. That was something that Verizon requested, so that SIs, if they needed to point and add directional support for certain tough situations, that there was something available for that. And with Cisco, who OEMs our platform, we partnered with Cisco and built a cellular radio that snaps onto the back of a Cisco access point so that it's a zero infrastructure installation. You literally drop the AP down from the ceiling, plug the cellular radio in the back of it, and the services node kind of coordinates and sets up all the PCIs within the radios and brings the network up and online. So it's one of those things where we're trying to, as best as we can, to reduce the barriers to entry and to allow the SI community to do things in a much more faster and efficient manner.
All right, thank you, Art. Wade, please go ahead.
Hi, Wade Sarver, Wade for Wireless. I have a blog and a podcast, but I talk about deployment. I've been in deployment over 30 years in the RF industry. I've done paging, I've done two-way systems, I've done public safety, and I've done a lot of public safety DAS years ago when you had to put it in these old buildings and they didn't care how it looked. You just dropped the antenna in, you put something low power in, a repeater, and a BDA. It was fairly straightforward. Now in today's world, everything is digital, so you can't just wing it anymore, you know what I mean? And aesthetics really matter, especially here in the city. Well, it's a deployment guy that has to deal with all the problems. I mean, we basically take his small cell, put it into his antenna, and use his test equipment to optimize it. That's basically what the field team does, and that's what I really talk about. That's what I've done for over 30 years, and I've done it for DAS, I've done it for macro, I've done a lot of small cell deployments, I've done for carriers and for a lot of public safety stuff too. It's just one of those things that I think without the deployment teams, the integration teams, you're really missing a big piece, because it's normally the integration team that has the final inspection, the integration team that also has to deal with the customer, deal with the OEMs, and make it all work. And, I mean, look up. You got to make it look pretty if anything's in here. You know, you got to figure a way to make it blend. because, you know, you also have to do the engineering on site and a lot of the site surveys. So that's it.
Hi, thank you, Wade. So as you can see, a broad spectrum of kind of the ecosystem around mobile infrastructure, and obviously parts of it would include the antenna. So I'm going to go to our first question. And I think what I'm going to do for time is combine this question with the second question a little bit. So all of you have obviously worked in this area for a while. So the question one was more about the current design considerations and for what you do around the mobile infrastructure, DAS system, small cells, and antenna. What do you kind of see as the most important design considerations today and what you're doing? And then the part two of that question, what do you see coming? What's the roadmap item you see coming that's going to affect the design considerations of how you do what you do today with the deployment of mobile infrastructure, DAS systems, or small cells? So with that, I'm going to play a little trick and let you go first again.
Okay. So looking at current situations and testability, the biggest concern that we as a manufacturer of test equipment has is being able to translate what the carrier demands, what the contractor, system integrator, and OEM, their goals are, and what the customer requires for a good UE experience. And I'm going to hit on three areas that are very suitable for today's environment, particularly in DAS. When we look at a DAS antenna and we measure coverage, we take an antenna from one of the manufacturers here, and we say that that antenna has a coverage capability of X amount of feet diameter. And we often use a tool like IBWave in order to look at the layout and the deployment based on our SSI, based on power and coverage capability. What often isn't taken into consideration, particularly in venues like Manhattan, is the environment the building was designed in. We're sitting in a beautiful hall that has different types of structures, concrete structures, rebar reinforced structures. Perhaps there's an extension that was put in 10 or 20 years ago, also using different types of infrastructure. That affects the amount of coverage that that antenna, who on paper gives a particular coverage area, it affects how much real coverage is going to occur. So we need to be able to measure that coverage capability. We also need to be able to optimize it. When the venue is filled and this room has 300 or 400 people in it and everybody is looking to demand a real-time video, the amount of power demanded from the infrastructure, the remote radio head, the copper feed, the BBU, to that antenna increases. When that bandwidth increases, the potential for noise increases. That increases the possibility of PIM, or passive intermodulation. And the third one is really regarding first responders. A first responder comes in an emergency situation. Someone has to validate that we know there is coverage in every stairwell, in every elevator shaft, in every bathroom. So addressing the first part is the ability to be able to take a look with your test equipment, whether you're sweeping something or you're taking a signal source and a spectrum analyzer and measuring the coverage with indoor coverage mapping. You would take a spectrum analyzer with a JPEG of the venue itself, and you systematically walk the entire venue for 1, 2, or multiple technologies, and you measure that RSSI. For public safety, you'll measure the EVM. Looking at how the system coverage works when the BBU is powered up very high is going to be different from when there is a smaller amount of power coming into that baseband unit. So in those instances, in a new installation, I would use a PIM tester to simulate the BBU at its highest amount of traffic. Place the antenna in the intended location from that IBWave design file, input full base station power, and see what that antenna looks like when it creates PIM. Perhaps move the antenna 2, 3 feet away from a metallic object and see if that improves the coverage of the antenna, and then relocate it on the drawing and mount the antenna before construction is completed. The advantage of that is we don't have to go into a tenancy that's already occupied by high capital tenants and ask them to be inconvenienced with a nighttime move when they just put a significant amount of dollars into a capital improvement. For public safety, we need to be able to assure that there's coverage in that stairwell, but we can't do that without having GPS capability. So what we do at Anritsu is we have a small transponder unit that can actually measure the elevation. So the transponder unit is used in coordination with a spectrum analyzer tuned to the carrier frequency or multiple frequencies. As I walk the building, I capture that information roughly 1 time a second through elevation, through floor to floor, and across the entire horizontal plane. And I can go back using my design tools and determine where I have nulls in the system that may require a repeater or a change in the boost, change in the power, or an alternating azimuth on an antenna. And then the third aspect is the ability to do that sizing. When you're designing for testability, you're measuring the PIM for full size and capacity. You're testing the interior coverage to make sure the design works. You're testing it for public safety. The third aspect is combining all of these disparate pieces of test into a single report. And we've created tools that allow the carrier and the contractor to output a single report for being able to test that entire infrastructure. And the same goes for the area of transport, which goes to Mike's second question, where is it going for future challenges and considerations? We're seeing more and more fiber deployments. Fiber is being deployed over higher speed backhaul, and the front haul is converting that backhaul, whether it be anything from a DS0 to OC192, into a digital transmission called CPRI, the Common Public Radio Interface. We need a way to test those CPRI circuits easily and quickly to match whether the CPRI converter in the remote radio head is the same as the CPRI device in the base station. We need to be able to make sure that the optical transport in the front haul is properly sized. By that I mean, are the connector losses correct? Are there bends in the fiber around a piece of molding that causes it to attenuate? Are there breaks in the fiber? Is there a dirty connector? These challenges are put forth to a group of technicians and field engineers who are used to working in copper. Most of our industry is used to working in 5/8, 7/8 inch and 7/8, large diameter pieces of electrical componentry. And now we're telling them they have to use a piece of backhaul that's 1/5 the diameter of a human hair. So it's a challenge in training, it's a challenge in understanding, and we have to span the technology and the techniques people know with what's coming. So getting the analogies across to the field, understanding that copper and fiber can be synonymous is very important. Understanding that CPRI is just a conversion from optical to electrical to RF, and the tools to test it are the challenges that we face as test equipment manufacturers today. Thank you, Mike.
All right, thank you, Ray. Well done, well done. And Bob, please.
Very good. I'm actually going to address a little bit about 5G in this scenario here, where you have a, let's say, a passive network now. It's all hard line that's all pulled through ceilings and whatnot. In order to go towards 5G, you're really going to need active antennas at that point. And what that's going to require is that's going to require your downlink being down converted at the head end to an IF. The IF is transported through the existing infrastructure. At the far end, you're going to want to up convert that and amplify that in the antenna. Now, in order to have an antenna that's out there and operating, you're actually going to have to revisit some of your splitting and combining networks, some of your directional coupler networks, because they don't pass DC. You're going to need to power the antenna remotely from the head end, and that's going to present certain challenges, let's say. As far as concerns, again, it's an active device in the ceiling. Some operators, some landlords may not like that, but at that frequency range, it's really something you've got to address, and you have to go with active antennas. Some of the other concerns that you're going to have is this hysteria about near far. You can actually address that by using a high IP3 in your first active component in the antenna on your uplink. That would directly affect your near far, and the problem would generally go away. So, lessons learned, future development. That's pretty much where I am.
Go ahead, Art.
Yeah.
On.
Our, our lessons learned tend to be around design and site walk in advance. Because when you're working with small cells, you have only a certain amount of power you can radiate. So you're either going to assume a certain macro interference level and maybe have to add infill radios later when you don't dominate the macro, or you do a good data collection in advance, drop it into your design and get your radios placed in the right place. So it's really doing your homework around macro dominance and the effects of the outside world network is key for a small cell installation. And it's, you know, from the future, we're looking at things like directional antennas, beamforming to UEs, that kind of thing. Whether or not the cost of the silicon is going to get there so that you can steer and direct a beam to a UE at a cost-effective price point, you know, we don't know, because right now we're very simple. When you look at our model inside IB Wave, it's just a nice spherical globe of unidirectional power. But from a power and reach perspective, if we can do beamforming, there might be some unique things that could be done in the future. So that's kind of, you know, where we're looking at on the antenna developments is what else could happen on more the active antenna side.
Wade, please go ahead, Wade.
Okay. So lessons learned, it's a big thing. When you have deployment teams, you learn a lot of lessons. Let me tell you, learn quick. One is the training. You want to make sure everyone's trained for the job they can do, because we talked about it here. We went from copper to fiber, different types of cables, different types of connectors, different ways to mount different antennas, and the way you're actually going to put the equipment in. The other thing you have to do is you have to be ready to install the equipment the way you're supposed to. How do you do that? You do that with a survey, a site survey. You go out ahead of time. That's a big lesson learned. Years ago, people were trying to cut corners, right, to save costs. So they would skip the site survey and go off pictures, or they would trust the customer, which is lesson learned number 3. When you're working with the customer, they'll tell you what they want. Then you have to guide them to tell them what they should have. I'm not saying push them into something they don't want, but if they want coverage in the building, but they want the lowest price possible, you have to find that balance there. That's a big lesson learned, because, and it's the same way with the carriers. Macro, indoor DAS, very similar situations. When you're dealing with a customer, they're going to want the cheapest thing with the best coverage, and you're just going to have to find something in between and guide them. Now, the final lesson I'm going to bring up today is you want to be clear about what you're going to do. That's why IB Wave is great, because you can lay out what the expectations for the coverage are, and you'll test it at the end. You want to know exactly what you do have, and if it's not what it should be, you look at your antennas. Is the antenna placement right? Is the power settings, are they all correct? I got one more too. Testing ahead of time, like PM testing. That was another shortcut a lot of people tried to get rid of, especially in small cell deployments. They tried to skip the PM testing. So when you're planning this out, you want your people trained properly. You want to do your survey to know exactly what you're going to put in. You want to work with the customer and set the expectations. I'm a big fan of writing a well-detailed scope of work ahead of time. It's a lot like your construction drawings. You want everything done ahead of time so you can show them and they know what to expect, okay? You want to lay everything out that way. And then when you do your testing, it should match your design, obviously, and if it doesn't, you better know why quickly. Because the customer's counting on you to sign this off quickly, efficiently, and they don't want to pay any more money than they have to.
All right, thank you, Wade. So now the next question really relates to a couple things, but mainly it's around, can you maybe go into a little more detail and describe a recent project, something that's kind of been one of your more challenging projects recently, and kind of go through again both what you had to do and kind of what it tells you, you know, beyond the lessons learned, what you will do next time from what you've done. So if you can just come to mind, each one of you with an example of maybe one of recent challenging projects and kind of what you saw as things that have to happen or things you definitely will take care of next time. So I think kind of Wade, you got into it a little bit, but let's start again with Greg and say there's one in particular that you can share with the audience to learn from.
So tagging off of one of Wade's comments about being able to follow a procedure. Had a situation recently in the Southeast. It was a brand new fiber deployment. It was this particular carrier's first remote radio head AWS deployment. They had 160 RRUs that were going in. These were brand new sites where they already had a single carrier in copper. It was the first diplex site where they were putting fiber up. All the equipment was inventoried to a warehouse. All the equipment was delivered. Inventory successfully matched all the components. Installation occurred. There was no pre-testing of the fibers beforehand. So the fibers came in reels. The RRUs came packaged with the SFPs nicely vacuum packed. BBU had SFPs vacuum packed. Everything's installed, turned up, and out of the entire installation, we had over 50% of the units were showing no received signal at the RRU. So the first thing we do is we start doing optical testing. And not surprising, connectors were put in, they were somewhat dirty, so we went ahead, cleaned, inspected those connectors, only to find out that some of the cables were kinked because the fibers came in large reels. The reels were forklifted into a truck. The forklift blade sometimes hit the outer jacket of the fiber and caused it to break. If the carrier contractor did a quick inspection and an incoming, they would have seen immediately before any connectors were terminated that there were breaks in the fiber. They wouldn't have pulled the fiber at a significant cost, and we would have ordered new fibers, pre-tested them, and installed them. The other real surprise is the SFPs, the small form factor packages on the BBU and on the RRH, weren't the same. We had this disparate batch of black painted SFPs that were all supposed to be 1310 single mode. A whole handful with 1300 multi-mode. Well, if you've worked in fiber, you know single mode and multi-mode talk together about as well as oil and vinegar mix. It's not going to work. And that's what happened. We did a quick test on the SFPs from the ground, found out that the tower SFPs were the wrong wavelength, had to have another tower crew deployed. The good news of the story is it became a great training exercise. The senior ops manager for the state realized that this was a big mistake with multiple people involved, used it as a training event, asked us if we would stay on site an extra day and cycle through many of their ops technicians and other contractors, not to point fingers, but to say these are the things to look out for. Just an example of a recent situation that turned out to be good in the end, but was very costly and frustrating at the time.
All right, thank you. Bob?
Really, the only one that comes to mind, I mentioned it earlier, was the New York Hilton. Was a system that we had there with fiber. There were issues with the head end because they had it deployed in an IT room, and the IT room was not air conditioned, so we had to bring in an air conditioner to blow on the head end equipment to stop it from failing. That was problem number one. The head end was also installed in the same room where they had a lint vent, and there was a door on there. You know, the girls would dump the sheets in there and whatnot, and that would go down to the dryers. The lint would come out of this door thing and jam up all the fans and the power supplies and whatnot, and we had to have somebody go out there and vacuum it frequently, as I recall. The next issue came, again, dirty environment, fiber. We had fiber that would run up to, I believe it was the third floor from the head end, went into our chassis where we converted over IF frequency back over to fiber and then sent that out to the radio heads. That was all fine and dandy, but in that same chassis, we fed from the third floor to the sixth floor via daisy chain. And then from the fifth floor, I think it was, up into the 8th or the 10th. And the same deal. On the back end of this cage, this IF converter, you had the remotes, you had your antennas deployed on there. Problem comes when either someone needs to charge their cell phone in the IDF closet where you have these located, or somebody's plugging or unplugging the fiber. In the case where the guy's charging his cell phone, he unplugs the cable from the quad box. Since these systems were daisy chained, we lost half of the building. That was a big deal. Fortunately, he or she unplugged their cell phone, plugged the remote back in, everything recovered. But then we began to experience fiber issues after that, and we believe it had to do either with the lint or the environment where these things were installed. And To make a long story short, our customer, the operator, was upset with us that we daisy chained, even though it was in their best interest and it was very cost competitive, one of our greatest features. But the operator, hindsight, said why we didn't run home runs from the head end out to each of these IF boxes instead of daisy chaining. So lessons learned, we did the right thing for the customer. It wasn't exactly what the customer wanted, but maybe miscommunication to the sales guy. I'm not sure.
All right, thank you very much. Art, one more?
A lot of our kind of, the stories are more like high-pressure installations as far as a customer moves into a building. They have no signal because it's a new green building, and there's like literally nothing inside. And because the CIO had a relationship with the CEO of the mobile company, he was able to pick up the phone and say, fix it or else I'm gone by the end of the week. And we rushed a system out and got it up in service. And because he was the CEO, he was able to get backhaul in place in 3 days, which is something an ordinary mortal can't do. And I think the other situation that we came up with that was very unique on an installation side was during a site survey, customer wanted a small cell in all 8 of their elevators. And we had to go out and figure out how to source Cat 5e cable that was industrial rated and rated to go up and down in an elevator and kind of live to tell about it. And had to build out small cells into every elevator for the building because people wanted to be able to hand into the elevator, go up to their floor, and then hand into the system on the floor. So it was kind of a unique challenge, just more to figure out the materials and get all the cabling in place to successfully pull it off.
I have a very specific story. So I apologize. I'll try not to go too long. But we installed a DAS system for a carrier, okay? I was a solution architect on the offer, and I put everything together. It's just frustrating when I think about it. So you put everything together for them, beginning to end. You tell them what to do. You write up the scope of work, and this is common with carriers. You basically lay out the equipment, everything you could. You work with their engineers, and we knew what building we were going to put it in. And we had the layout, the design, did the survey. We did all this up front. And what does a carrier do? Of course, they pull it back and they do a reverse auction. I don't know if any of you are familiar with working with the carriers. That's where they pull it back and then they try to get other contractors to do other pieces of the work. Well, the problem was they changed a lot of things from the original scope of work. This is why I'm such a fan of a scope of work. And if you're in deployment, you like to have everything laid out step by step. I do in writing because you tend to catch things in writing that you wouldn't catch by just explaining it or having just a checklist. So I do a very detailed scope of work. So what happened was when they had these crews do it, they decided to change where they were going to put basically the BBU in a different room. Of course, the room had no air conditioning. I don't know why they moved it. They just did. There was no, we had everything set up in the contract, set up ahead of time. But they didn't tell us. They had the contractor do that. They had the site act team do that. Well, of course, now you have no cooling in this, a closed room, somewhere in the basement. The other thing they did, when they mounted the, we were working with a DAS system. I won't say who the vendor was. But when they ran the fiber, they didn't run it in the chase like we had wanted them to. They picked another way to do it to save time and money, because again, another vendor did it. And they cut certain things out of the scope. They thought they were saving money, right? They took a lot of shortcuts. Shortcuts that the customer meant, oh, we're saving money. We just knocked 10, 20, 30 grand off this installation. Meanwhile, the day comes to turn everything up, and you can imagine what happened. It was a nightmare. BBU overheated. They had to put an air conditioning system in. That was extra money. They had to rerun a lot of the fiber because, one, they didn't run it where they were supposed to. Hit number two, because you have to be very specific, especially with landlords, about how you're going to run the cable. And I'm sure I'm preaching to the choir here. Everyone probably knows that. The other thing is, the way they mounted the radio heads was not the specification that we had required in the beginning. Hit number three. Now the landlord's mad. The landlord's mad at the carrier, not us, because we were pretty much pushed out of it. Not happy with the contractors that the carrier hired. And what they did, big mistake, they just took every shortcut they could do. The site survey that we originally had, they ignored that and they went in a different room. I don't know why, But this is a very specific situation where you should have somebody that can see this thing through beginning to end, whether it's a project manager, whether it's a deployment engineer, whether it's just somebody on your team that you trust to see it from design to where you bid on it. Bidding's a big one if you have to bid on it, and explain it to the customer what's going on, all the way to implementation and testing. And the reason I say that, obviously you guys, probably a lot of you do that here, but you want somebody who understands the process beginning to end. Sometimes, you're working with an OEM and maybe they have a problem or they have to do an upgrade, or maybe there's a newer firmware. It's very important to understand all that ahead of time, because when you get the equipment, you want to make sure everything's up to date. You want to make sure the cables run exactly, the fiber, the RF cable, doesn't matter. You want to make sure it's run exactly how you specified it was run. Now, I know a lot of you guys are saying that's crazy, you don't know until you start running it. I get that. But if you do a good site survey, if you work with the landlord, the building engineer, the maintenance engineer, whoever it is at the building, they can usually tell you how things are going to run. Now, I know your installation crews, when they show up, things are always a little different, and you have to, adapt, improvise, and overcome all the hassles that you have out there in the field. But again, have a very specific scope of work, because if you have to make a lot of changes that are outside of that scope, you just have to expect to issue a change order and get paid for it. If you don't have your specific scope of work, if you just say, I'm going to get the DAS system up and running, that's it. God knows what kind of costs you could run into that you just weren't prepared for. So again, this happens a lot with carriers because they do pull things back, but what you have to insist on is that they follow the original plan that you set up. Write it out, write a scope of work. It's going to help them, it's going to help you. Everyone's happier in the end. They just don't know it in the beginning because they see dollar signs, and they don't want to see any more dollar signs than they have to. So.
Thank you, Wade. Thank you very much. So we have a few minutes left right now. We did kind of speed it up a little bit, but we're kind of at the edge of our time. So first of all, any questions from the audience at all? Just to ask you now very quickly. You can hit it. Otherwise, I'm just going to ask the pass for a one-sentence summary. That's it. A one-sentence summary about what's happening with the mobile infrastructure and also antenna and technology in particular, because that's what this panel is about. Any questions? It looks like no. Drinks aren't next, by the way. I just want to remind you, they're not next. There's one more panel at least and a closing statement. So with that said, thank you, panel now, but give us a one sentence. Let's go the other way. Wade, you're first this time. So we're going to just one sentence of all the things we've just said. What would you like to leave the audience with as a summary?
Plan ahead.
Good design.
DAS is no different than macro.
Make sure you can test what the customer and the carrier demands.
I'll just add, make sure you have air conditioning, because I heard this common thread of air conditioning where your equipment is very critically important as well. So with that, I want to thank the panel. Thank you very much. And we're going to set up the next panel. Alyssa, back to you. Thank you very much.